Hello everyone, this is Balaji.K.R signing in for Brain Smart Labs. And with me over here is my... Excuse me, who is this? Hera! Buswali!
What? Buswaliya? Why are you here? నిన్ను చంపడానికి.
You mean kill me? ఎందుకో?
ఆఖరిసారి నువ్వు నాకు ప్రోగ్రాం సరిగా అర్థం చేయించలేదు, అందుకే.
అమ్మా బుస్వల్లి అమ్మా, నన్ను క్షమించు తల్లి.
నిన్ను క్షమించాలా? వజేతుల్ కాశ్మీర్ రోజు నిన్న నిప్పుతో కాల్చి చంపకపోతే నా పేరు బుస్వల్లి కాదురా.
ಏನೋ ಸಮಸ್ಯೆ ಇದೆ.
ಇವನೆಲ್ಲಿಂದ ಬಂದಪ್ಪ?
ಬಾಲಾಜಿ ಅವರೇ, ನೀವು ಪಾಠ ಮುಂದುವರಿಸಿ. ಈ ಬುಸ್ವಲ್ಲಿನ ಹೇಗೆ ಸಂಭಾಳಿಸ್ಬೇಕು ಅಂತ ನನಗೆ ಚೆನ್ನಾಗಿ ಗೊತ್ತು.
ಹೌದಾಚಾರ್ಯ, ನೀವೇ ಸರಿ ಈ ಬುಸ್ವಲ್ಲಿಗೆ ಬ್ರೇಕ್ ಹಾಕಕ್ಕೆ.
నా దారికి అడ్డొస్తున్నావా వరే కుక్క?
ಹೋಗೆ ಕೋಳಿ ಪುಕ್ಕ. ಅಲ್ಲಿ ಆಚಾರ ಬಂದಿದ್ದಾರೆ, ಈಗ ನೀ ಮಾಡ್ಕೊಂಬೇಡ ಕಕ್ಕ. ಹೆಂಗೆ ಡೈಲಾಗ್?
ಬಾಲಾಜಿ ಅವರೇ, ನಿಮಗೆ ಪಾಠ ಮಾಡಿ ಅಂತ ಹೇಳಿದ್ದು, ಪಿಜೆ ಹೊಡೀರಿ ಅಂತಲ್ಲ.
ಅಯ್ಯೋ ಶಿವನಿ, ಯಾಕಪ್ಪ ಇವರಿಬ್ಬರ ಮಧ್ಯೆ ನಾ ಸಿಕ್ಕಾಕೊಂಡ್ಬಿಟ್ಟಿ. Why to waste our time? Let us start with our new chapter, Autopsy of your first Java program.
Before directly jumping into our next chapter, let us take a quick recap on our previous session.
In our previous session, we basically focused on, first we saw downloading Java development kit onto our PC. We then saw how to install Java in our computer. We also saw how to configure path variable and class path variable on Windows operating system. By this, we understood the need of path variable and class path variable settings. Once all settings were in place, we started writing our first Java program on the Notepad application and saved it as demo.java. We then compiled the Java program using javac command on our DOS prompt. Last but not the least, we executed our program using Java command and got the output hello world.
Well, in today's class, we will be seeing what made Java to give your first program output.
Mystery behind Hello World output.
The Hello World program, what you executed yesterday, included 3 stages.
Where A. Writing the source code included the program you wrote on the notepad and saved it on the file demo.java. B. Compilation was a stage where you compiled the file on the DOS prompt using javac command. And finally C. Execution was a stage where you used Java command on your DOS prompt to run the program and you got your output.
Well, frankly speaking, you will not understand head and tail of the above concepts even if I give you 1 hour lecture on what is it. Trust me, I know who you are and I know how you think. ಅಯ್ಯೋ ಸರ್ ಬರೀ ಥಿಯರಿಗೆ ಹೋಯ್ತಾರಪ್ಪ, ಏನೂ ಅರ್ಥ ಆಗಲಿಲ್ಲ. The reason for you not understanding my lecture is my words are not touching your experience. Whatever I tell you, it will be mere words and you will be one more Ishant Avasthi of Tare Zameen Par.
खो न जाएंगे तारे ज़मीन पर.
So the only solution to avoid the above scenario happening is my lecture should touch your experience. And if that happens, trust me, you will start understanding every word what I tell you in my class. Hey, ಏನು ಮಾಡಿದ್ರಲ್ಲ ಸರ್, ಸೂಪರು, ನಂಗಂತೂ ಎಲ್ಲ ಅರ್ಥ ಆಗೋಯ್ತು. I will give my level best to make you understand every word in my class. But ಅಷ್ಟಕ್ಕೆ ಮುಗಿಲಿಲ್ಲ. Even you should practice everything what I teach you. Funda is simple. You practice the programs of each class before starting the next class. And boom, you can understand the subject very easily. But if you don't practice the previous day programs, ಸಂಘ ಮಕ್ಕಳ ಒಡಿಸ್ಕೊಳ್ಳಿ.
Understanding Java's architecture.
Dear students, Java was not built in a day. Well, for that matter, no computer language in this world was built in a day. First, there was binary language for programming where everything was coded in zeros and ones. As it became very hard for the developer to code everything in zeros and ones, he then invented assembly level language for programming. Soon as the requirements grew, he invented high-level languages like Pascal, Fortran, C and C++. I know all of them will appear prehistoric in today's world, but each stage had its own improvement, and every programming language what I mentioned above followed a basic foundation principle. That is, writing of source code, converting it to machine code and execute the program. To understand how things work inside Java, first we need to understand how things work in these prehistoric computer languages. Well, if you directly jump into Java and start learning Java's architecture, you will not understand head and tail of what is there inside. In fact, this is a stage where all self-learners fail and then blame Java is difficult, Java is difficult. In learning, we should always go step by step. So what are we waiting for? Let us start understanding how things worked in binary language.
How things worked in binary language.
I know you have studied this in college and many people would have experienced writing binary code on microprocessor 8085.
Hope you can remember during MP 8085 lab, your instructions were initially written on a piece of paper and then physically verified by you.
Fun thing was, this piece of paper where you used to write all lines of code was known as a source code. I know what used to happen those days. Once you finish writing your source code, you used to walk in full Shraddha Bhakti towards your ma'am, who used to simply kill her time filling your attendance.
And you would have said, Ma'am, I finished writing the source code, ma'am. For which she would have said, Aita bardiddu, go take the opcode table and start writing the machine code.
And guess what this opcode table was? It used to contain all operation codes for various instructions in your microprocessor. And our fate was
Manually convert this source code into machine code with the help of this opcode table. Like 0101, 1011, 1010, 1111.
once you finish writing your machine code, you used to run to your ma'am for taking her permission to execute. But what to do? Your ma'am would be very busy talking to her boyfriend.
Guskusu pispiso, guskusu pispiso. But the moment you approach her, she'll be like, Hey, I'm in the lab, okay? Call me in the evening, na? See ya, bye-bye. Take care. Cuts the phone and asks you, Ella mugita.
Once your ma'am approves your program, I know you would have ran towards the microprocessor set and start typing your machine code.
0101, 1011, 1010, 1111.
What you actually did here was store the program in some memory and then try to execute. That's it.
Your processor then would have munched the machine code line by line of what you have stored in the memory and provided you the required output.
And guess what you used to program back then? Addition of two numbers, subtraction of two numbers, swap two numbers, delete two numbers, and other keystone circus. The main disadvantages of binary programming was A. You could write only smaller programs, B. No compiler to verify your errors, and C. Manual conversion and verification of opcode led to so many errors that you cannot imagine. Ultimately, these disadvantages led the developers to a totally new stream of programming, assembly level language.
How things worked in assembly level language.
After binary language, then came the assembly level language for programming. Here, initially the source code was typed on a simple text file. A virtual component by name assembler verified the source code and reported you the syntax errors if any. Once the assembler confirms that there are no more syntax errors in your source code, it then used to generate the machine code and store it in your memory all by itself. And once again over here, your processor used to munch the machine code line by line, which gave us the required output. The assembly level language programming had two main advantages compared to binary. It had faster process as assembler verified the source code and converted it to machine code. It used to generate fewer errors as verification process was completely automated by the assembler. But the main disadvantage here was we could write only smaller programs and execute them. If at all you wanted to do some bigger programs like hardware interfacing, you know how we used to struggle in our college lab exams. Stepper motor question bandre saku bye badkontidvi. So this led us to the next level programming, high level languages.
How things worked in high level language like C.
In high level languages like C, the process gets more sophisticated than your assembly level languages. An entity by name compiler compiles the source code before the execution takes place, which gives us syntax error-free object files along with link file and an executable file. In short, an exe file. These can also be called raw material for your machine code. Please note that the validation process will go more strict as C is a high-level language. Let it be any language for that matter. More strict the compiler, better the quality of your machine code. The linker, also known as the link file, links all the object files with the operating system you are currently using. I mean to say, if you are using a Windows OS, the link file that gets generated will be specific to Windows operating system. If you are using a Linux operating system, the link file that gets generated will be specific to only that version of Linux. The object files, that is raw materials for your machine code, will always be tightly coupled with the operating system you want to run on in languages like C and C++. The .exe file, also known as the executable file, contains the native code to run your program. Native code simply means the machine code for the operating system you are currently executing on. The exe file, when triggered to run, loads the native code on the RAM for the processor to execute it, and we get our output. Many high-level languages today have a similar architecture, and Java, as it is the most sophisticated high-level language, it has an interesting architecture we all have to look into. But warning, stay very attentive over here. The basic concepts I am going to teach you now will be applied to any program you run on Java. ಗಮನ ಏನಾದರೂ ಅಲ್ಲಿ ಇಲ್ಲಿ ಹೋಯ್ತು ಸತ್ರಿ ಮಕ್ಕಳ ಜೀವನದಲ್ಲಿ ಒಂದು ಜಾವಾ ಪ್ರೋಗ್ರಾಮು ಹೆಂಗೆ ವರ್ಕ್ ಆಗುತ್ತೆ ಅಂತ ಬಾಯ್ ಬಿಡ್ಕೊಂಡ್ರು ಅರ್ಥ ಆಗಲ್ಲ. ಹುಷಾರ್.
How things work in Java language.
Initially, your source code, that is demo.java, will be compiled using javac command bearing the full file extension, that is javac demo.java. Your compiler will check for all compilation errors in your source code for what you have written. If any errors are found, it will be displayed here below so that you can correct your source code wherever the error is pointed and recompile it again. If no syntax errors are found, your compiler then generates something called the byte code, that is your demo.class file, in the same directory location where you have kept the source code. One thing you should remember for your interview is the byte code which just got generated is not the native code which runs as .exe file as it happened in C. Remember, in Java there is no linking between the class files as it happened in C. In C, the .obj files were tightly coupled to one another and firmly linked via linker. These files were bound to run on the same operating system where it was compiled. In C language, if you take these files away and load it on a different operating system, the code never used to run. This phenomenon is known as platform dependency, and by this you can infer C is a highly platform dependent language.
ಅಣ್ಣ பிளாட்ஃபார்ம்னா பஸ்ஸு ட்ரெயின் வந்து நிற்குதே அதா லே என்னடா ஆச்சு உனக்கு நார்மல் ஆயிட்டியாடா எப்படிடா அது ஒரு பெரிய கதை அப்புறம் சொல்கிறேன் இப்போ சொல்லு வாட் இஸ் கோயிங் ஆன் வாட் ஆர் யூ டீச்சிங் கண்ணா யூ மிஸ்ட் ஆல்மோஸ்ட் ஹாஃப் ஆஃப் த கிளாஸ் உனக்கு ஒன்றும் தெரியாது இப்போ என்ன பண்ணுற எப்போவுமே கிளாஸில் அலர்ட்டாக இருக்கணும் தெரியுமா யார் சொல்லிந்து நான் அலர்ட்டாக இல்லைன்னுட்டு I was using my subconscious memory power like our emotional ஏகாம்பரம் சார் you see. You were telling C was not a platform independent language because it cannot be compiled in one system and executed in another system with a different OS. Correct தானே? எப்படிரா அதெல்லாம் தனி டேலண்ட் ஒரு அண்ணாக்கு மட்டும்தான் தெரியும். You continue. இந்த மாதிரி ஸ்டூடெண்ட்ஸை நம்பி நான் கிளாஸ் பண்ணணும் என்ன குடுமை சார் இது.
The above concept of platform dependency, which was present in C language, is not at all applicable for Java as it is a highly sophisticated language.
In Java, the source code which gets converted to bytecode is always the same when generated in any operating system in any part of the world. You can even transfer these bytecode files to another operating system where Java runtime is installed and try running the same. Believe me, your code will run clean as a whistle. This phenomenon is known as platform independency, and Java has become very popular among developers as it is a highly platform independent language.
Dude, I completely agree platform independency is a good feature. But how it is possible in Java? Why not other computer languages? Now there's the point. The secret lies in Java's internal architecture. The founders of Java gave it the best design, which made the language highly platform independent at the same time highly reliable. Come on, let's start seeing how Java was designed from the inside.
Java's internal architecture.
Whenever we try to execute a .class file using Java command, that is by typing java space demo on your DOS prompt, your .class file gets loaded onto the Java virtual machine, in short known as JVM. The JVM has a virtual component by name class loader, which helps it to retrieve the required .class files from the file system. The loaded .class files is then verified by a component by name byte code verifier to check whether the retrieved .class files are tampered or not. If the files are found tamper-free, the execution engine starts executing the bytecode by interpreting it line by line using something called just-in-time compiler. It is during this stage, native code for our bytecode is generated by JIT compiler using something called bytecode interpreter line after line.
Once again, native code here means the machine code that can be only understood by the operating system you are executing on.
For every line of bytecode being converted to native code, your CPU munches the machine code to give you the required output.
Dude, wait. You're confusing me by saying source code, byte code, native code, blah blah blah. I am seriously not able to understand what you're trying to say. Please explain the difference between them.
Of course, I will. The source code in Java is your file where you wrote all lines of code on Notepad and saved it as demo.java. The bytecode in Java is your .class file that gets generated during compilation of your program. When you compile your source code using the command javac demo.java, the demo.class file that got generated is nothing but your bytecode. The native code in Java is nothing but numerical ones and zeros that gets generated by JIT compiler after interpreting your bytecode line by line. Now everything clear? Have you understood everything in Java's architecture? Can you explain it to me, mister? Subconscious memory power. Oh sure, why not? Initially our source code is compiled using Java compiler to generate the bytecode. Please note that there is no linking between the bytecode and the operating system as it happened in C language. Your bytecode is then loaded onto the JVM with the help of class loader, and it is then passed to bytecode verifier to check whether the bytecode is tampered or not. Once the verification is done, the execution engine starts interpreting your bytecode line by line to generate the native code, which is only understood by the operating system you are executing on. Our operating system will then instruct our CPU to munch the native code as it arrives to give us the required output. I told you na, it's all tiny talent. Puru annakku mattumda theriyum. You continue. In C programming, the compiled version of your source code was tightly bound with the operating system, and because of which you could not write a program in one operating system and run it on another operating system.
This is the main reason why C failed miserably in the field of application programming.
Whereas in Java, the bytecode which gets generated is not at all coupled with the operating system. You can literally compile the file here in one operating system, take the .class files, dump it on another operating system where JRE is installed, and your code will run clean as a whistle.
The Java runtime environment installed in your operating system will be equipped with its own JVM specific to that version of operating system. Java is designed in such a way that all your bytecode needs to run is a JVM, no matter what operating system you are running on. Wow, now I get the real essence of why you were saying Java supports Vora, write once and run anywhere. That's real platform independency. But I have a doubt. Can you just repeat once again what is that bytecode verifier and what does it do? I still don't get why JVM checks for tamper-proof bytecode files. I know it's something related to security, but security against what? What will happen when it runs tampered bytecode file? The JVM which is designed is very sophisticated as it does not accept any tampered .class files. The reason being, once a bytecode is tampered by a human or a bot on purpose and accidentally your JVM consumes the same, it will be prone to errors. Trust me, letting tampered bytecode files run on your JVM is like letting your entire machine crash and go for a reboot. You may not see it as a big problem when you're trying to execute your chilre palre hello world programs. But imagine, big programs accessed by millions of users are loaded onto your server. These programs will be doing hell lot of transactions that you can never imagine. Any runtime errors at any instant of time would make your server crash and go for a reboot. It may even lead to catastrophes like loss of customer data, loss of business, losing court cases, $1 million compensations, firing of CEOs, companies taking over. Here is a point you should understand without fail. The bytecode in your .class file can only be understood by your Java virtual machine or the JVM present in your Java runtime environment, aka your JRE. Your JVM can only be invoked by java.exe command present in your bin folder. This is the command which will instruct your JVM to consume the .class file with the help of a class loader. In your interview, they might ask, in Java, what converts bytecode to native code? For which your answer would be just-in-time compiler. Just-in-time compiler, also known as the JIT compiler, reads the bytecode line by line and converts it to native code for your processor to execute. They might also ask what is the difference between Java compiler and JIT compiler, for which your answer would be Java compiler is used for compilation and syntax verification, whereas JIT compiler is used in execution of a program. Java compiler converts source code to bytecode, whereas JIT compiler converts bytecode to native code line by line and sends it for execution. Java compiler is a true compiler which compiles the entire file in a single stretch, whereas JIT compiler is an interpreter as it executes the bytecode line by line. A programmer invokes a Java compiler using javac command, whereas JVM invokes the JIT compiler while starting the execution engine. These differences might be asked in your interview, so be ready. It's my sincere request to all students to make notes of everything what I say in class. Things what I say in class are very important for your interview. While preparing for interview, all you need to do is just revise these points what you have written. That's it. Well, if you don't make notes, you will definitely repent it later. Mind it.
Ladies and gentlemen, introducing White Venkat.
ನೋಟ್ಸ್ ಬರೀತಲ್ಲ ನೀವು, ನಿಮ್ಮ ಗುರು ಮಾತು ಕೇಳ್ತಲ್ಲ ನೀವು. ಓಪನ್ನಾಗಿ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ನೀವು ನೋಟ್ಸ್ ಬರ್ಕೊಳ್ಳಿ ಬಿಡಿ, ನಾನು ಮಾತ್ರ ಬೀದಿಗೆ ಬರಲ್ಲ. ಅರ್ಥ ಆಯ್ತಾ? ಕೋಟ್ಯಾಧಿಪತಿ ನಮ್ಮಪ್ಪ ಬಿಲ್ ಗೇಟ್ಸು ಲ್ಯಾಪ್ಟಾಪಲ್ಲೇ ಜನ್ಮ ಕೊಟ್ಬಿಟ್ಟ ನನಗೆ. ಅರ್ಥ ಆಯ್ತಾ? ಬೇಕಿತ್ತ ನಿಮಗೆ ನಾ ಇದೆಲ್ಲ ಹೇಳೋದು? ಆಲ್ ಅಮೆರಿಕನ್ಸ್ ಆರ್ ಮೇಕಿಂಗ್ ನೋಟ್ಸ್ ಸೀಯಿಂಗ್ ಮೈ ವಿಡಿಯೋಸ್. ನೀವೆಲ್ಲ ಯಾರೋ? ನನ್ನ ಯಗ್ರ, ನನ್ನ ಮಗನ್. ಅಣ್ಣ ಕೂಲ್ ಡೌನ್. ಇವಾಗ ಏನಾಯ್ತು ಅಂತ ಇಷ್ಟೊಂದು ರೈಸ್ ಆಗ್ಬಿಟ್ರಿ? ಏನಾಯ್ತಾ? ಇನ್ನೂ ಏನಾದರೂ ಬಾಕಿ ಇದೆಯಾ ಆಗೋದು? ಪಾಪ ಇವ್ರ ಅಪ್ಪ ಅಮ್ಮ ಇವ್ರ ಜಾವ ಕಲೀಲಿ ಅಂತ ಹೈ ಸ್ಪೀಡ್ ಇಂಟರ್ನೆಟ್ ಹಾಕಿಸ್ಕೊಟ್ರೆ ಪೋಲಿ ಪಿಕ್ಚರ್ ನೋಡ್ತೀರಾ? ನನ್ನ ಮಗನ್, ಯಾವತ್ತಾದ್ರೂ ಚಪ್ಪಲಿ ಕೊಡಿಸಿದ್ದೀನ್ರ ಅಪ್ಪ ಅಮ್ಮಂಗೆ? ನನ್ನ ಮಗಳ ಚಪ್ಪಲಿ ಸೈಜ್ ಗೊತ್ತೇನ್ರ ನಿಮಗೆ? ಪೋಲಿ ಪಿಕ್ಚರ್ ನೋಡ್ತೀರಾ? ಹುಡುಗಿರ ಜೊತೆ ಚಾಟ್ ಮಾಡ್ತೀರಾ? ಶೋಕಿಗೋಸ್ಕರ ಇಂಟರ್ನೆಟ್ ಪ್ಯಾಕ್ ಹಾಕಿಸ್ಕೊಂಡು ವಾಟ್ಸಾಪು ಸ್ಕೈಪು ಗಂಟೆಗೊಂದು ಸೆಲ್ಫಿ ಚೇಂಜ್ ಮಾಡೋದು ಇದೆಲ್ಲ ಬರಬೇಕು. ಬಾಲಗುರು ಸೇನೆ ಕಟ್ಬಿಡ್ತೀನಿ, ಗೊತ್ತಾಯ್ತಾ? ನನ್ನ ಮಗನ್ ಲೇ, ಯಾರಾದ್ರೂ ಆರಸುರ ಲ್ಯಾಪ್ಟಾಪನ್ನು ಅಡಚಣೆಗಾಗಿ ಕ್ಷಮಿಸಿ. ಶೀಘ್ರದಲ್ಲಿ ನಿಮ್ಮ ಪಾಠ ಮುಂದುವರಿಯುವುದು. ಈಗ 2 ನಿಮಿಷ ಮೌನ.
Experimenting on your JVM real time.
Now let us go for some practical examples to understand more about your JVM by performing certain experiments.
Experiment number 1.
The .class file that gets generated from your Java compiler takes the same name as a class name present in your source code. Please explain. Well, that's simple. Your source code has a class inside. Agree with me?
Yeah, we have named it as class demo with DS caps. So,
Now you compile the source code file, you will get a bytecode file. Agree?
yeah, it's the demo.class file that gets generated in the same folder where our source code is present.
True. In this experiment, we are trying to find out what will happen when we change the name of the class inside our source code to class hello instead of class demo. Now once you save and compile this file, what would be the compiled output file name? Will it be demo.class or will it be hello.class?
ಶಿವನೇ ಸಾಂಬುಲಿಂಗ ತಗ್ಲಾ ಕಣ್ಣ ಲಾಪ ಏನಪ್ಪ ಬರತ್ತ ಔಟ್ಪುಟ್.
Well, there is only one way to find out. ಕಣ್ ಬಿಟ್ಟು ನೋಡಬೇಕು.
ಇದೇನಲ್ಲ ಇದು ಹೊಸ ಫಿಟ್ಟಿಂಗು. ಡೆಮೋ.ಕ್ಲಾಸ್ ಬರುತ್ತೆ ಅಂತಿದ್ರೆ ಇದು ಯಾವುದೋ ಹಲೋ.ಕ್ಲಾಸ್ ಬಂದು ಕುಂತೈತಲ್ಲ ಶಿವ, ಇದೇಂಗ್ಲಾ ಸಾಧ್ಯ?
It's simple.
When compiled, you will be getting hello.class because the .class file that gets generated takes the same name as a class name present in your source code and not your source code file name.
ಅದೆಲ್ಲ ಸರಿ ಗುರು. How do you run this program? We don't have a file by name demo.class, right? So we can't use Java demo to run it. Exactly.
If you run the program using the command java demo, you will be getting the following error, which simply means your JVM is not able to find demo.class as it does not exist in that particular location.
Okay, so how do we run it? Java hello? Bullseye. For compiling, you have to use javac demo.java as it is a source code. But to run the program, you need to use java hello as hello.class is present in this location.
ಸೂಪರ್ಲ ಮಗ, ನಂಗೆ ಗೊತ್ತೇ ಇರಲಿಲ್ವಲ್ಲೋ ಈ ಥರ ಆಯ್ತದೆ ಅಂತ. ಥ್ಯಾಂಕ್ಸ್.
Industry standards.
Supporting the above concept, we have an industry standard to name the source code file same as a class name as circled here. Both names should exactly match and should have same uppercase and lowercase alphabets to avoid problems during post compilation.
Experiment number 2.
It is always the .class file that gets loaded and executed and not the source code file.
Wait, let me guess. Now this means source code has nothing to do with the execution of the program. Am I right?
ಒಳ್ಳೆಯ ಅಲ್ಲ ಮಗಳ ಗಂಡ, ಅದನ್ನೇ ನೀನೇ ಹೇಳ್ಬೇಕಾ?
To prove this experiment, we need to edit the source code file, that is demo.java. Change the SOP statement hello world text as let's see. Yeah, in pinda. Save the program but don't compile it for time being.
Guys, we have a point to prove over here. We can compile this file later, but for now, pay your full attention over here.
Observe the timestamp of both source file and class file. As you can see, the source file is modified at 10:15 am, which is a newer version compared to your .class file which was generated at 10 am. Now try running this program on your DOS prompt by typing java demo. You're getting the same old hello world output even though you have modified your source code as Ninpinda. The reason is simple. It is your .class file which is being loaded and executed by the JVM and not your source code file. If it was your source code file, you should have got your new output in Pinda by now.
So this proves your source code has nothing to do with the execution of your program. Once your source code is compiled by your javac command, katam gatam. Your JVM will never consider your source code for execution even if you modify it for 1,000 times.
Now the only way left for you to get the new version of the output is by compiling the file, which makes us again do javac demo.java. This command will again compile the file to generate a newer version of demo.class file. Once your compilation succeeds, you will be getting a newer version of .class file as seen here. Hope you can observe the byte code which is generated at 10:22 am.
This is the latest modified time compared to its source code, which was modified at 10:15 am. Now let us run the program using the command java demo. Ta-da! There you go. You can see a new output in Pinda. Happy? Congratulations! Please understand that javac and java commands are nothing but your exe files present in your bin folder. You can call these files on your DOS prompt only by the particular bin location by default. But as we have performed the path setting I taught you in my previous session, you will be able to invoke the command staying in any location pointed by your DOS prompt. Is there any simple way to program, compile and execute our code in one single place? Programming in Notepad is a real pain in the beep. And it's very deep. Ayyo papa. That leads me to teach you a mind-blowing editor by name Edit+, which will make your job simpler and effective, as it is a more sophisticated editor than your Notepad for programming. Start noting down.
Installation of Edit+.
Install Edit+ with the world famous method of clicking Next, Next and Finish. Open Edit+ application and to your left, go to the address bar and reach your program location. In our case, it would be D drive, workspace, basic examples and 01 simple program. Organization matters everywhere and Edit+ has a file manager to your left. This will display all the file contents in that particular folder location. Use it to your best advantage to create and save your new files and folders. Edit+ is just a simple editor, just like your Notepad. The main advantage of using Edit+ over your Notepad is it makes your program looks good as the text is color coded. The keywords here are highlighted in blue and the text strings are highlighted in pink, which helps you to differentiate what is what in a program. One more major advantage of using Edit+ over your Notepad is easy one-click compilation and execution, which avoids us to shift to our DOS window each time while programming. One-click compilation, one-click execution. Can anyone teach me how to do it? There you go.
Settings in Edit+ for easy compilation and execution.
Click on Tools, Preferences, and then click on User Tools. Click the button Add Tool and select Program. Now name the program as Compile. Locate the address of bin folder I showed you in my previous class and select javac.exe. For argument, please select $filename. And for initial directory, please select $file_dir, which is very specific to your compile command. Enable capture output feature and click on apply. Similarly, create one more tool by adding a program by name run. Now locate the address of bin folder and select java.exe for this tool. For argument, please select $filename no.ext. Enable capture output feature and click on apply and then OK. With this, you have successfully created user tool commands for compile and run in your Edit+. Now to work with these tools, you need to go to View and click on Toolbars. Click on User Toolbar to select the same and there you go. You can see the compile tool bearing the shortcut Ctrl 1 and the run tool bearing shortcut Ctrl 2. All you need to do is press Ctrl 1 for compilation and Ctrl 2 for execution. Now with these settings, it becomes very simple and easy to compile and run your programs. All you need to do is press Ctrl 1 for compilation and Ctrl 2 for execution. That's it. Don't worry much about the other options in Edit+. It's just a better way to program than programming on your Notepad. We'll be using more sophisticated IDEs like Eclipse and NetBeans in later stages. Just concentrate on how to set your tool groups, create new programs, compile them and execute them. That's it. Katam Gatam. Make notes for all things what I say in class or you will end up in soup later. Try out the Hello World program in your newly installed editor and get some first-hand experience using the same. Send your doubts on WhatsApp if you have any. Do understand, you understanding the subject is our topmost priority. Subscribe to this channel and stay updated for our next video release. Until then, this is Balaji.K.R signing out of Brain Smart Labs. See you soon. Till then, bye-bye.
ನೇರಾ ಬುಸ್ವಲ್ಲಿ ಹೆಸರು ವೈಟ್ ವೆಂಕಟ್ ಮೇಷ್ ರಾಶಿ ಭರಣಿ ನಕ್ಷತ್ರ ಓಕೆನಾ